Let's talk about the easiest way possible to find out what the answer to a horizontal asymptote problem is. So, what I like to use is what a lot of people refer to as the leading behavior method. When you look down at a problem, we really should be able to tell in about 2 seconds, based upon the leading behavior of the equation, what that equation is doing, what our horizontal asymptote is looking like, that long term behavior. So, I've broken it down into three options. I call option one top heavy. When we're talking about horizontal asymptotes, we're looking for what is known as the dominant term, or at least that's what I call it. It's the leading behavior. It's the equation, it's the part of your equation that's going to dominate how the rest of the equation works. So usually what you're looking for in these situations is the highest power of x. That's always going to be your dominant term. So as x gets really, really big, x to the fifth would what I call dominate x to the third, right? The biggest number you can possibly think of taken to the fifth power is going to dwarf that number taken to the third power. And so when we look out for the long-term answer here, the horizontal asymptote, we're always looking for the dominant term. So when I use terms like top-heavy, as we look at these equations, you're going to always kind of have fractions. So if I had something like limit as x approaches infinity, it's where the location of the dominant term is. So when I say top-heavy, I mean the top of the fraction. So if you look down at your page and the top of this fraction is where the dominant term is located. So if you just had a bunch of stuff like this, you can see that the dominant term would be x to the seventh here. And so what that's basically telling us is that the top of this thing is headed off to infinity, and there is nothing that the bottom can do to stop it. That x to the seventh power is just getting huge. So the top of the fraction is where the leading behavior lives. That's why I call it top heavy. And what that's doing is that's basically just leading our graph up to infinity. So you always need to be careful if that x is headed to positive infinity, maybe it's headed to negative infinity. You might have to determine which direction this thing is headed. But you know that the answer is infinity, and you just have to say to yourself, okay, is it going up? Do I have a positive number that I'm getting out every time? Or is it going down to negative infinity because I have a negative number every time? So that's option one, top heavy. Option two in this situation is just sort of the reverse of that. It's what I call bottom heavy. And so what that tells us is that our dominant term is on the bottom. So if we said limit as x heads to infinity, and we have this time x to the fifth plus 3x squared minus 9 on top, and this time the x to the seventh, that dominant term, is sitting on the bottom there. Well, the dominant term is on the bottom this time. And so what's happening now is that's where the really big number is happening. So when you think about it mentally, you really have 1 divided by this huge number. So 1 divided by a huge number would be a decimal point with a ton of zeros, right? And then a 1. And so as that number gets bigger, as it heads to infinity, you're just going to keep getting more and more decimal points. So this thing is really going to be getting closer and closer to 0. So whenever you've got a bottom heavy scenario, you know that your answer is always 0. So you would have a horizontal asymptote at y equals 0 always in these situations. And so again, it's just sort of, you think about it, your graph would be doing something like this, heading down to 0. That reminds me that, you look over here, these would have no horizontal asymptote, right? The long-term behavior is headed to infinity or potentially negative infinity, depending upon what direction you're going, whether you're headed this way or that way. But there's no horizontal asymptotes there. Then our third option, our last option here, is just what I call balanced. And so balanced means that the top and the bottom are growing at the same rate, that there's an equal dominant term, an equal leading behavior on top and bottom. So maybe we have something like 7x to the 13th plus 8x to the 5th over 5x to the 13th plus 9x to the 4th plus 27x. So here our dominant term are these x to the 13ths. So on top and bottom, this thing is growing at the same rate right now. The only difference, though, is the top one I'm always going to multiply by a 7, and the bottom one I'm always going to multiply by a 5. So then I know that the coefficients of those dominant terms, that's always going to be my answer when I have a balanced situation. When the top and the bottom are growing at that same rate, they have equal leading behavior, equal dominant terms, then my horizontal asymptote is always just going to be the coefficients. So we'd have y equals 7/5. That'd be your horizontal asymptote or your long-term behavior. And so you'd have a graph that's sort of over the long haul would head towards this value of 7/5. You don't know which direction from, but somehow it's headed that way in the long term. So horizontal asymptotes, you can break them down into 3 scenarios. So you should always know what you're looking for. Based upon the leading behavior, where is the dominant term? Is the dominant term on the top of your fraction? Then that means the top is growing out of control and there's nothing the bottom can do to stop it. Is the bottom part of your fraction where the main growth is happening? And so then if that's where your leading behavior is, you're really looking at 1 divided by a huge number, which is always going to head to 0. And then the third option is you've got equal dominant terms on top and bottom. And in that scenario, whatever the coefficients are of those terms, that's what your long-term behavior will look like. That's what your horizontal asymptotes will look like. You might have to do more work by hand depending upon the test question or the class question. But you should always know if your answer is right or wrong on a horizontal asymptote question in about 2 seconds.